Hi guys, today we're going to look at day 3 notes from Unit 7 where we are talking about vertical dilations. I want you to understand by the end of class today that a vertical stretch makes a function narrower and a vertical compression makes a function wider. And this is done by multiplying the y values. So what we're going to see is numbers like, 2, 6, -4, 1/2, 2/8, 4/3, things like that multiplied on the outside of a function. And then we're going to have to see how that changes the graph. So it says consider the function f of x equals x squared minus 4x minus 5. The functions g and h are defined by the formulas g of x equals 2 times f of x and h of x equals 1/2 times f of x. Determine the formulas for both g and h in simplest trinomial form. So we'll start with g of x. It says that we take 2 and multiply it by f of x. Remember, f of x is x squared minus 4x minus 5. But it's not in simplest form until we distribute the 2. So now we have g of x equals 2x squared minus 8x minus 10. And we'll box this in. Then for the next one, we have h of x equals 1/2 times our function f of x. And again, distribute that 1/2. So we have 1/2 x squared minus 2x minus 5 over 2. You could say that that's minus 2.5. That's fine. It's up to you, whichever you prefer. So the next part says, using your calculator, sketch and label each curve on the set of axes below. Use the window indicated by the axes. And by that, we're saying that the x's should go from -3 to 7, and the y's should go from -20 to 20, as you can see on the axes below. If you're using a TI Inspire, here are the steps to adjust your window so that you have x's -3 to 7 and y's -20 to 20. If you don't have a calculator with you, that's okay. You can always just follow along with me. If you do have a calculator, I suggest that maybe you pause the video, type in your equation, look at the graph, adjust your window, take the necessary steps to be able to do this on your own, because you will have to be able to do stuff like this on your test. Being able to type functions in your calculator and looking at the tables, so on and so forth. Now when we sketch these, they are just rough sketches. If we type in f of x first, what I have up here boxed in purple, when we look at the graph, it passes through -1 and +5 on the x-axis. So when we sketch this, we're going to make sure that it passes through -1 and +5. We're going to label this as f of x. Then we're going to type in the next equation that we boxed in as g of x, 2x squared minus 8x minus 10. This one again passes through -1 and +5, but it's a little bit taller and narrower, deeper than the original, this one being g of x. Taller, narrower, deeper. Now we can type in the third function, 1/2 x squared minus 2x minus 5/2. This one again still passes through -1 and +5, but this time this one is wider, shallower, and what's another word to describe this? Flatter. This is h of x. So I'm going to give you some values down here. Again, if you have a calculator, follow these steps for finding minimums on a TI Inspire. If you don't have it, that's okay. Just follow along with me in writing the coordinates. So for the F minimum, the purple graph's lowest point, it's at 2, -9. For the G minimum, the lowest point is at 2, -18. And the H minimum is at 2, -4.5. So it says, what points did not vary when f was vertically dilated by factors of 2 and 1/2? Explain why this happened. So we can actually just look at these minimum points. You can see that I start with 2, -9, and then I move to 2, -18. So we're asked which did not vary, which did not change, and we're going to say the x's. The x's stayed at 2 and 2. Even when we compare 2, -9 to 2, -4.5. The x's stayed the same because we only multiplied the y values by 2 and 1/2. Remember how we had that 2 times f of x, or the 1/2 times f of x? These are Voy problems. Voy changes the y's. Y's got multiplied by 2. X's stayed the same. That's important when we do these dilations. We are never going to talk about dilating the x's. We're only ever going to talk about dilating the y's. Yes, it's possible to dilate x's, but we're not going to focus on that in this course. So again, when we do dilations, it's always only affecting the y values. Let's flip it over so we can do a little summary. So a vertical stretch makes a graph tall and narrow and occurs when y values are multiplied by k greater than 1, where k is a scale factor, so maybe you want to write that in. This would look something like f of x goes to 2f of x, or 3.5 f of x, something greater than 1. A vertical compression, notice the difference in these words. Stretch is tall and narrow. Compression is short or flat and wide, and occurs when y values are multiplied by 0 less than k less than 1. And again, that's referring to the scale factor. So this might look something like f of x goes to 1/2 f of x, or 1/4 f of x, or 2/5 f of x, something between 0 and 1. So in this next example, it really gets at the fact that only a particular variable is multiplied. So we start with this point, -312. Maybe you want to label it as xy. And it's on the graph of y equals f of x. Then it says, which of the following must lie on the graph of 3 times f of x? This is Voy, so we only multiply y's. Voy outside y's. So we keep -3, then we take the 12 and we multiply it by the scale factor of 3. So we have -3, comma, 36. Choice 2. Let me give you another example or two off to the side here so that you can practice independently. So say that we start with the point 4, 6, and I want the coordinates after, let's do 4 f of x. So give me the new coordinates. Remember that we keep the original x value and we multiply the y value times 4. 6 times 4 is 24. So you should have had 4, 24. Let me give you another one. I want the coordinates of the point after 1/2 f of x. So in this case, I kept the x value of -2, but then I took the y value, negative 10, multiplied it by 1/2, and that gave me negative 5. All right, we're going to talk about the transformations that have occurred and the order, but we're not going to graph. I don't want to focus on the graph of two things right now. We'll focus on that more in the upcoming days. So order of transformations is important. And we're going to write them down off to the side here. And then we'll talk about what's actually occurring. So first, we have to do horizontal shifts. That's your left and right. Second, we do reflections. That's your negatives, like negative f of x or f of negative x. Third, we do dilations. Then fourth, we do vertical shifts. That's the up and down. So you can see that we start with working on the inside of parentheses, and then we work our way towards the outside. So in this first problem here, we have g of x equals 2 times f of x minus 3. So if I look at this, I don't see anything inside the parentheses with the x, which means that we can skip 1, and then I look on the outside, and I see just a 2 being multiplied by the function, which means we can also skip 2. So then the third one is a dilation with a 2. So we have to think, is that a stretch or a compress? If it's greater than 1, multiplying, say, your height by a scale factor of 2, that means that you're getting taller and skinnier, most likely, right? You're stretching. So this is a stretch by k equals 2 on the y's. K equals 2 means the scale factor is 2 on the y's and only the y's. Then I take a look and I see this minus 3 on the outside. Minus 3 on the outside is void. Void changes the y's, so that's a down 3. So we stretch it by 2 and then move it down 3. Let's flip to the next page. Let's talk about example 5 here. You could do example 4, but let's just focus on 5. So it says that we have a quadratic that has a y-intercept of 12. Remember, y-intercepts are where you cross the y-axis. So we're up here at positive 12. So then it says, which of the following is true about h of x equals 3g of x minus 5. So remember that we work our way from the inside out, so we have to figure out what's happening first. There's nothing on the inside, so we move towards this first outside with the 3. Remember that 3 is a stretch by k equals 3 on the y's. So we take the y value and multiply by 3. Multiply y's by 3. That's our first step. Then the next part has that minus 5, so we are moving down 5. So the second step is to subtract 5 from the y's. So we're going to do this all to that y-intercept of 12. So 12 times 3, that was our first step, and we get 36. But then we have to take that 36 and subtract 5 from it. 36 take away 5 is 31. So the new y-intercept is 31, meaning choice 4. Let me give you another one off to the side. Say that our initial y-intercept is 12. And we do this to the function h of x equals 1/2 f of x plus 8. So what's the new y-intercept? Take a minute to try that on your own, and then check back in with me to see your answer. So final answer here should be 14. You can see my steps listed out below. If you need more time with this problem, just hit pause. Otherwise, come work with me on the practice. So this first practice problem says that we're going to sketch 1/2 f of x, meaning that we are shrinking or multiplying y's by 1/2. So we're shrinking or compressing towards the x-axis. So what we do is we take a point, say 0, 0, and we have to shrink it by 1/2 towards this x-axis. Well, 0 times 1/2 doesn't change. The next one, though, I'm up 1, but I have to change that up value by multiplying by 1/2, because we're only changing the y's. I don't change the x's, just change the y's. So 1 times 1/2 is 1/2. So I plot a point at 1/2, if my pen will work. There we go. Okay. Then I move towards the right one more time. I'm right here, up at 2. Take 2, multiply it by 1/2. 2 times 1/2 is 1. So I plot a point at the value of 1. Then I move to 3. I'm up here at 3. I multiply that by 1/2. 3 times 1/2 is 1.5. So I go from the x-axis up 1.5. Then the next one, we're up at 4. 4 times 1/2 puts me up at 2. Not up 2, but up at the value of 2. Then we're up at 5. 5 times 1/2 puts me at 2.5. And you can see how this pattern can keep going. It's okay if you just choose to do the evens, meaning like this next one over here where we're up at 6, because that gives you a nice value at which you would move to. 6 times 1/2 is 3. Oh, I guess that one was, what did I do? I'm jumping ahead, I'm sorry. I already did the 3 one, then 3.5, then 4, 4.5, so on and so forth. That's towards the right. Now we got to do towards the left in the same fashion. I'm currently up at 1, so cutting that in half puts me up at 1/2. Then I'm up at 2, cutting that in half puts me up at 1. Up at 3, multiply by 1/2 is 1.5. Up at 4, multiply by 1/2 is 2. So on and so forth. Go ahead and finish out that second part of your graph here. If you need more time, just pause the video, otherwise move on to part B with me now. So this time we have 2 times f of x, meaning that we are multiplying y's not by 1/2, but by 2. So x's will stay the same, but our y's will grow by a factor of 2. So again, starting with 0, 0, 0 times 2 keeps me at 0. The next one, I'm up at 1. 1 times 2 puts me up at the value of 2. Not up to, but up at the value of 2. The next one, I'm already up at 2. Multiply that by 2 puts me up at 4. After that, I'm up at 3. I'm doubling my distance, so now I'm up at 6. The next one, I'm up at 4. Double or multiply by 2, so now we're up at 8. The next one, up at 5. Multiply by 2 puts us up at 10. Then do the same thing on the left side. Alright, so here we have 2f of x graphed. If you need more time, just pause it. Otherwise, flip to your homework so that we can talk about which problems you're going to do tonight. Alright, so we're going to circle number 1. We're going to actually fill this out together right now. If it's a stretch, this means that k is greater than 1, like 2, 3, 4, 4.5, 8, 10, 1,627,003. Something greater than 1 will make your graph tall and narrow. If it's a compression, that means k is between 0 and 1, like 1/2, 2 or 3/5, 1/4, things like that. Fractions less than 1. This makes it wide and flat. And in each of these cases, remember that we only multiply y's. Only the y's. Okay, so that means that we are going to do number 2, number 3, number 4. Go ahead and give number 5 a try. So all of the front page. Flip it over so we can talk about the back. I want you to try number 6. Skip number 7. And try number 8 for me. And I want to kind of give you a hint here. You definitely need to describe what's happening first. And then when you graph it, you may want to graph the transformations separately. So by this I mean first do one transformation, then use new graph to do the second transformation. And again, you'll see the answers for this once you turn in your homework. If you have questions on it, that's okay, we can talk about it. But you are doing all of the front side and then 6 and 8 for this back side. Remember that you can go back, pause, rewind, whatever you need to do to make the best use of these videos as possible. I know that these transformations, especially dilations, are a little bit tricky, but the main thing that you need to remember with dilations is that it only changes the y's, because we're only talking about vertical dilations, stretch, or compress.